taken my favorite maiden, Coco. We must attack his castle.
Sir, we could use our new secret weapon.
What is our new secret weapon?
The Trebuchet.
Oh!
I'm in love with the Coco.
Oh, hello. I'd like to talk to you a little bit about the physics of a trebuchet. So, one of the first concepts involving the physics of a trebuchet is the law of conservation of energy. So, with a trebuchet, there's a weight at a fixed point, and when it drops, it gains kinetic energy. But at the fixed point, it has gravitational potential energy. And as it drops, the gravitational potential energy is changed into kinetic energy because the weight is losing height while gaining velocity. This causes a change from gravitational potential energy to kinetic energy, keeping all the energy in the system and showing the law of conservation of energy. Now let's take it over to my friend Greg outside, who will tell you a little about centripetal acceleration. Oh, hello. I'm Greg, D1 Harvard bound for golf. Let me tell you a little about the physics of a trebuchet. Let's talk about centripetal acceleration. So, using some previous concepts, we found that the force that the ball is in relation to the long arm is 39.513 newtons. So that equals 9.07185 kilograms, which is the weight of the weights times the acceleration. Then you find the acceleration to be 4.35 meters per second squared. So at the moment of release, it's traveling at 4.35 meters per second. Using this velocity, you put it in a centripetal acceleration formula, which is velocity squared over radius, so you get 4.35 squared over 21 centimeters, which is the distance of the trebuchet. You get the centripetal acceleration to be 0.90337 meters per second squared in relation to the tip of the long arm. Oh hey, didn't see you there. I'm Kyle, Professor and Gamer, MLG. So I'll talk to you a little about the projectile motion physics involved with the trebuchet. So we found the angle of release on the trebuchet to be 50 degrees. We found this by counting the frames, measuring it, protractor, all that fun stuff. So we also found the time the ball from the trebuchet takes from the top of the trebuchet to the ground to be 2.1 seconds. We found the speed in the last problem to be 4.3 meters per second squared, or the acceleration rather. So all that was left to find the distance. So to find the distance, we did 4.35 meters per second squared over 2.1 seconds. Using simple algebra, we found the ball traveled 9.135 meters before hitting the ground. Now let's cut to my brother Mark and show a demonstration.
Sire, Sir Wellington is coming to steal his fair maiden Coco. We must protect the castle.
Coco and I will be safe here. Nothing short of a trebuchet will be able to break down these sturdy walls. Attack! Sir, I can't get through these walls!
We must use the trebuchet! I desire my fair maiden, Coco.
Oh no! Castle Morningwood's walls cannot hold against this attack.
Castle Morningwood's walls have been breached. Onward, let us attack! My fair Coco, I've missed you, babe.
Now let's talk a little bit about projectile motion. So, the angle of release is 50 degrees.